I'll repeat that. If distance equals rate times time, and I asked you to solve that equation for time, what would you do to both sides? By what? R. So for the questions today, one of the things that you're going to be asked to do is to write an expression for time, and the way in that you are going to do that is you are going to take the distance divided by its rate. Okay, Megan, in some of these questions you're going to notice I'm going to have a down and back trip, and in that case the distances are going to be the same. Okay, and then I might tell you what the times add up to be or something like that. In other problems, I'm going to tell you two different distances because it goes faster and then slower, and we'll set the times equal to each other. But in both questions, this is key. Can you write a time in terms of a distance over a rate? Okay. All right, first question. Sandra is rowing a canoe on Stanhope Lake. Her rate in still water is 6 miles per hour. So if you've ever kayaked or canoed on a stream or a river, usually what way do they put you in? If you went with like a company, don't they drop you in somewhere? Who's done that before, by the way? Nobody in here has ever gone kayaking. Okay, tubing on a river. Who's ever tubed on a river before? Okay, don't they put you in the river? Yeah. What happens? You float. Why? Because there's a current. Okay, guess what would happen if they asked you to go back to where you started from? You'd probably need a paddle, and it would be kind of tough, correct? Because you'd be working against the current. So if you are canoeing on a lake, then maybe that's not going to happen because there's no current. But let's say the wind picks up, okay? And there's a current now. It's going to take her 3 hours to travel 10 miles round trip. And there's a current now working with her and against her. When is it going to work with her then? In which of these? Downstream, okay? Downstream's going to be faster. Okay. First of all, since this is a down and back scenario and the total distance is 10 miles, what can we assume about the distance she goes upstream? 5. The distance she goes downstream is 5. In some of the cases I'll show you on your homework, those distances are different, okay? All right. For the rate, what we're going to do is either you're going to be given the rate in still water, or you're going to be given the rate of the current and you don't know the other one.
Where did you get the 5 from?
It's a 10-mile round trip down and back. So I just split it in half. So we know her rate in still water. Agreed? What is it? 6. We don't know the current though, right? Let's call it C. The current is going to be added to her rate when she's going which way? Downstream. Downstream's easier, so her rate should be faster. When she's going upstream, then it's working against her, so it would be 6 minus C. Okay, here's the part where this is what this means. This doesn't mean try to figure out the time of each. This box is here for you to do the work of this. Would you rewrite the time as distance over the rate? So over here, 5 over 6 minus C. How about here? 5 over 6 plus C. Okay. In some of the questions today, you're going to see that I'll say something like, hey, they're the same time, and then you'd set them equal to each other. In some other cases, I'm going to tell you the total time, okay? That's this case. What's the total time it takes Sandra's trip? Why is this crooked? Hate that. There we go. 10 hours, right? Would you agree I would need to add these together to get my 10 hours? All right, so my equation is, I'm going to take 5 over 6 minus C plus 5 over 6 plus c, and I'm going to set it equal to, oh, not 10 hours, 3 hours, huh?
It's 10 miles.
10 miles. Yeah. Okay. This part, first part, is definitely going to be the most difficult of today, because this part now we've done already. I have two different denominators. How am I going to solve that?
Multiply by both.
Multiply by both. And some of the ones we do today, you're going to only have to multiply by one, which will be nice. And in some, you're going to just have to cross multiply. So we're going to multiply this side by both 6 minus c, 6 plus c. I'm going to just use my fingers to cover up things. If you need to rewrite things, write them out. We're going to multiply these two together. Okay, see the ones right next to each other? There's 3 things on top, 1 thing on the bottom. Would you agree that the 6 minus c's cancel? I'm going to cover them up with my finger. What's left?
30 plus 5c.
Okay, you want to go right to 30 plus 5c. I'm going to go do this, okay? But yes, you can go that. But you agree that if those two cancel, that's what's left? Okay, now let's go to here. I'm going to use my finger again to cover up the things that cancel. 6 plus c, 6 plus c cancels. What 2 things are left? 6 minus c times 5. Now, on this side, nothing cancels. So I'm going to multiply out 6 minus c times 6 plus c, and then distribute the 3. I'm going to go ahead and do that right now. What's 6 times 6?
36.
Do you see how I have a minus c and a plus c? That's going to tell me that the middle terms are going to cancel, so I'm not going to write them down. I have 6c minus 6c. Doesn't that cancel? All right. And then what's minus c times c? Minus c squared. All right. Let's distribute everything out and solve. We have 30 plus 5c plus 30 minus 5c Can somebody help me with 3 times 36? So then I have 108 minus 3c squared. Do you notice anything that cancels out? Which one? 5c and minus 5c. So what do I have left on that side now? 60 equals 108 minus c squared. 3c squared, sorry. All right. Most of the ones that you see today, there's an exception of one of them. If they're quadratics, you can solve using square roots. So what we're going to do on this, we're going to get the c squared alone, and we're going to take the square root of both sides. Would you subtract 108 from both sides? What's 60 minus 108? Negative 48 equals negative 3c squared. Somebody tell me what to do next. Divide both sides by negative 3. Bree, what do we get? Good. 16 equals c squared. Take the square root. It is a plus or minus, but if it was a solving question, like no words, we'd write plus or minus 4. Like when we did our scavenger hunt, there was one like this, and it was the square root of 9. You had to find plus or minus 3. Okay, but in this case, it's just going to take the positive 4 miles per hour is the rate of the current. Okay. So, I am going to set up 2 more with you. The solving part is not the new part. The setup part is, I think, the hardest part, okay? So we're going to do 2 more. One is similar to this, and then I'm going to show you a different one where I ask you where their times are the same. So in both of these, I have them adding up to a total. Okay, let's find some things here. Alicia's average speed riding her bike is 11.5 miles per hour. She takes a round trip of 40 miles. In round trip questions, the distance is going to be the same there and back. So what can you tell me from that piece of information? This is 20. This is 20. Girls, you can put them right here. Right now, please. Grab them at the end of class. All right. If I'm going with the wind on a bike, am I going faster or slower than if I'm going against the wind? Faster. So, do I know the rate without the wind? Do I know the bike rate without the wind? 11.5 miles per hour. So with the wind, I'm going to write the rate would be 11.5. What do you want to call the wind? W?
Yeah.
Plus W? And this is 11.5 minus W. Okay. Remember our trick from before. How do we write rate or time as distance and rate? Give me the first one, Gabe.
Well, I just wasn't reading my hand for that, but where did you get 20 from?
The 40 miles split.
On a round trip, you're going to have the same down and back.
Fair enough.
Jacob, can you give me the rate or the time for this one?
20 over 11.5.
Perfect. That means this would be 20 over 11.5 minus W, right?
Yes.
Okay. In this question, do you see I give you both of the times? So in this question, you literally can just pick one of them and set it equal to its time. Let's try one. It takes her 1 hour and 15 minutes with the wind. Let's pick the with the wind. I have an equation for the time. I'm going to set it equal to the time. So 20 over 11.5 plus W. Hey, 15 minutes, what decimal of an hour is that? 0.25, so this is 1.25. That would be one of the equations you could solve. What would you do to solve that? Just multiply both sides by 11.25 plus W, okay? Okay, can somebody give me another equation? It would give you the same answer. What's an alternative? What else could you solve?
Over 11.5 minus W.
Jacob says 20 over 11.5 minus W equals 2.5 because he saw that the trip against the wind took 2 hours and 30 minutes. You could solve this one by multiplying by 11.5 minus W on both sides. Both of these would give you the same answer for W. Okay? If you wanted to, you could add them together and add the total time together too. That would be the hardest one. You don't need to do that. Okay? I'm not going to do the solving piece. I know you guys can do that.